from LG Institute of Engineering and Technology in the Department of Electronics and Communication. Welcomes you to the session of wireless communication. Today I am going to discuss about Unit 6, that is Design Trends, with topic SDR. SDR means Software Defined Radio. So let's start the session. First of all, let's first revise the last session that we have discussed in the last session about some recent trends technology, that is about the wireless fidelity, then about the WiMAX, and in the last session we have discussed about the ZigBee 802.15.4 standard, its various topologies and the advantages and application of it. Now let's come towards the next generation technology, that is the software defined radio. First of all, why we choose the software-defined radio? Because it offers the flexibility, means user can update the version of that particular software-defined radio at a time, and obviously it has a more cost efficient than the other technology, and also easily drive the power network. So mainly, if you want to write the definition of the software-defined radio, then software-defined radio is a radio in which some or all the physical layer functions are software-defined. If some or all physical layer functions are software-defined, then this radio is called as a software-defined radio. Now, radios that provide the software control of board variety of modulation technique can be used for this purpose. Now let's come towards the various features that are supported by the software-defined radio. So various features are, it provides the multi-band, means either it can be used for the 2 GHz band to 4 GHz band, or for the multi-carrier it can also be used for the multi-mode. Means at a time 2 different versions can be supported at a multiple rate, means the higher rate and lower rate both can be supported for the software defined radio. Obviously the variable bandwidth, because bandwidth is a major issue when we use the antennas, because some bandwidth may be wasted because of not choosing the proper channel assignment technique. So this number of features are supported by the software defined radio by providing the variable bandwidth, and obviously the connectivity is also the major concern in case of the software defined radio. So multi-area by saving the particular rate, data rate, multi-mode, even the connectivity can also be provided. So these are the various features that can be provided by the software defined radio. Now let's see about the architecture, which type of architecture is generally preferred in case of software defined radio. So obviously the digital signal processing and film programmable gate array and microprocessor are the hardware platform on which we can implement this software defined radio, and the operating environment can be like of resource management of this hardware platform, that is the DSP, FPGA or processor can be used here. If we talk about the OSI model, then this type of architecture is applicable on the second layer of the OSI model, that is on the link layer protocol for the software defined radio. Here the next protocol for this is the wireless application protocol that can also be used for it. So if we want the diagram, then it will be like this. Here in this diagram you can see that there are some blocks like the antennas and channel coder, or the various platforms for the digital to analog converter and analog to digital converter. Here each type of block is connected in both the direction, means the photoplexing can be done, and here the modeling can again be done with all these blocks. So here you can see that all the blocks can be connected with the modeling features and the link layer protocol of the software defined radio. Here various software defined radio technologies that can be supported are divided into the 3 major categories. First category is the adaptive radio. Here this diagram is the Venn diagram for the different SDR technologies, that is adaptive radio. Then the second one is the cognitive radio, and the last one is the intelligent radio. Intelligent radio uses the basic concept of the adaptive radio as well as the cognitive radio. So now let's see one by one each one. So first we talk about the adaptive radio. Adaptive radio is mainly used for the communication parameters that can modify at a time. So here in this type of radio, which type of block diagram is generally preferred? So in this case, the output parameters are continuously varying, and these output parameters are given to the weighted factor, and that weighted factor are continuously modified and then again given to the intermediate state. So in this case of adaptive radio, the errors generated are very less. It also offers the greater degree of freedom in the adaptive process also. The next radio that can be supported is a cognitive radio. In this type of radio, system is aware of about the internet state and environment. In the previous case of adaptive radio, the output is a major concern, but in case of cognitive radio, it also takes care of the internal state also. So in this case, utilization will be more proper compared to the adaptive radio, and it also reduces the end user cost, because in this case each time the weighted factor should not be modified, or it can be carried out like a simple block diagram of the MIMO technique, that is multiple input and multiple output. If we talk about the last type of technology that can be supported by software-defined radio, then it is an intelligent radio. In case of intelligent radio, it is capable for the machine learning, various type of machine learning technique. Here you can also use the NFIX for this, means adaptive neural fuzzy network can also be used. Here it allows the radio to improve the ways to adapt to changes in the performance. Means adaptively changing information can also be passed using this intelligent radio, like in case of the adaptive radio we have seen, and it also uses the concept of machine learning, or it also uses the cognitive radio concept, means it uses the best feature of the adaptive radio as well as the cognitive radio and then generate the output. So this is the third case of the radios, that is intelligent radio, which is one of the most important technology for the software-defined radio. Next one is the advantages of the software-defined radio. So first is software to be reused across various platforms. Once you have developed the software for adaptive radio, you can also use that for the intelligent or smart radio also. Over the air, the remote programming can be used, means you should not need to go at that end user and change the programming. You can remotely change and reprogramming the complete network. It allows the bug fixing, means diagnosis of the error can be possible and can also resolve it. Here, reducing the cost in providing the end user will be provided, and also provide the best rate. If it provides the best rate, then it obviously offers the best connectivity also. Then let's talk about another technology for the recent one, that is the UWB, means ultra wideband. Now, first of all, why we use the ultra wideband? Because it offers the high data transfer and digital video that can be possible with it. The speed is about the 1 megabit per second, and one of the advantage of this technology is data consumption, or the power consumption for transferring the binary information is very less. It also provides the short range of operation, about 10 meters. It can be used like Bluetooth technology to transmit the binary information, it requiring the low energy consumption. So if you want to generate the UWB signal generation, the block diagram will look like this. Here the two diagrams will be shown. Here first is shows the frequency modulation. So here you can see that for the time domain behavior, the signal is given, and at a time in a frequency domain only one tick is generated, that is on 2.4 GHz frequency. Means the ultra wideband signal can be narrowed and then transferred by using the ultra wideband UWB technology. You can also see the same reason by using the in-phase modulation also. The first case is the case of the frequency modulation, the second one is for the phase modulation. In this, you can see that the phase will be changing for the first A pulse to second B pulse, and then from B pulse to C pulse. So the overall band that is transferred is in between the first, second and third, that you can see in this green color also. So this is the case of UWB signal generation. Various features about the UWB is obviously the high transfer rate, about the 1 megabyte per second can be transferred, low power consumption can be possible, and obviously to get the low power consumption and high transfer rate, you should have the higher level of signal. If you want the higher level of signal, then there should be a better signal to noise ratio, and better signal to noise ratio can only be obtained if you have the good immunity to external interference. So that's why here the immunity to external interference is one of the best features that can be provided by the ultra wideband, that is UWB. The next is let's discuss about the pros and cons of UWB. So first of all, let's talk about the advantages of the UWB, that is about the large channel capacity, because if you remember the equation for the sensor bandwidth formula, then in that case signal to noise ratio is given by V log to 1 plus SNR. So it can be get by using the proper amount of signal to noise ratio. If you choose the proper amount of signal to noise ratio, then it will increase our channel capacity. Then next is ability to share spectrum. Obviously the narrow bandwidth is enhanced to the large bandwidth. If the bandwidth is enhanced, so obviously the ability to share spectrum is more in case of ultra wideband. It also works with low SNR also, means if somehow the noise level will be increasing in the passing of signal, then it can be removed by removing the distortion that can be present or harmonics that can be present in a signal. So we can say that it has the ability to work with low level of signal to noise ratio also. Next is low probability of detection. Means if there is any error generated, that can also be solved by using this type of technology. Resistance to frequency jamming, and that's why it is used for the frequency modulation and in-phase modulation. Obviously has a high performance for multipath channel. Why multipath channel is necessary? Because there is not only a possibility that transmitter and receiver has a clear line of sight, that may be the obstacle present in between the transmitter and receiver, and it decreases our signal strength. And by decreasing the signal strength, the signal to noise ratio is affected. So to get the high performance in a multipath channel, this technique can be advantageous. There are also some limitations for this. UWB devices are the power limited. If you want the more power, then it cannot be used. And the next one is the higher frequency gain cannot be increased. Means for the frequency modulation, there is some limitation about the frequency choosing. And that's why you should keep these 2 points in mind while choosing or while working with the ultra wideband. Otherwise, it has this list of advantages also. So this is about UWB and SDR technique. If you have any queries or doubt regarding the session, you can ask me on my email ID. Thank you for watching.